All right, I had a few more notes in here under construction, but we've already talked about it. Case, aluminum, alloy, watertight, obviously, except for the holes in it, which make it not watertight. Laminated steel pole inserts, we know why they're laminated. You got the rotating magnet made out of Alnico, or I have permalloy, whatever that is, distributor, dielectric material, formica, bakelite, thermoset plastics, but that's not something we need to write down. All right, we'll look at a little bit at magneto speed. I don't want to spend too much time on this and make this too much of a thing because it's really not that important, I don't think. The more I think about stuff like this, the book wants you to have an understanding of it, and I can't remember if there's any Q&A questions on speed, but for the most part, as a mechanic, you don't design them, you don't get to choose them, you put them on the correct way, and if you can do that, you're doing pretty good. But magneto speed, it's good to do this to understand the relationship between spark and engine rotation. So the number of cam lobes, oops, what the hell am I writing? L-O-B-E, number of cam lobes, that is the breaker cam number. I should put that here. Breaker cam lobes, so we know what we're talking about, is equal to the number of poles in the magnet. So the magneto that you are building in the class has how many lobes on it?
Two.
And also you notice that your rotating magnet happens to have how many poles?
Two.
How many magnets does that make?
One.
Pretty much one. It could be two. Maybe there's a north inside there and a south inside. All right, so number of poles. All right, so a 2-pole magnet has a 2-lobe cam. It's pretty easy math. The formula is, no, just kidding. The number of high voltage impulses per rotation is equal to the number of poles times 2. So you have a 2-pole magnet. And if I turn it around 360 degrees, half, 1, how many pulses did I get?
4.
2.
Math 1.
The number of high voltage impulses per rotation is equal to the number of poles. Oh,
That doesn't make sense.
yeah, I wrote times 2 right here in pen. I think somebody goes, no, it's times 2. And I'm like, oh, okay, and I wrote times 2. It's equal to number of poles. That was right there. I don't know why I did that. That's not right. Number of magnets, if you wanted, no, number of poles. So, sorry about that. So, 1, 2. So the points are going to open and close twice. You are going to get 2 impulses. All right. So a 2-pole magnet. Let me make sure this is right. 2-pole magnet will produce. Yeah, this is right. So a 2-pole magnet will produce how many sparks? Spark events per 360 degree rotation, which is 1 revolution. So a two-pole magnet will produce how many spark events?
2.
2 spark events. All right, per revolution. All right, so we got that. Let's talk about the engine. So, I don't know if I love this statement, but it is true. The number of cylinders that fire per revolution of the crankshaft is equal to 1/2 of the cylinders. I prefer this statement. All cylinders will fire in 720 degrees of crankshaft rotation. So you can look at it one of two ways. One, how many times does a prop have to go around to fire all the cylinders? Twice. 720 degrees. So if you only went around, so if you had a 6-cylinder, make it easy math for you. If you have a 4-cylinder engine and it went around, prop went around twice, how many of those 4 cylinders are going to fire? All of them. 4. Goes around twice. What if the prop went around once? Half of them. What if it's a 9-cylinder radial engine?
1/2. Well, depends on which rotation.
So how many of those? So 9-cylinder radial engine.
It'd be either be 5 or 4.
So there's 9 of them. So it goes around. How many times does the prop have to go on to fire all of them? Twice. So 1 revolution, how many will fire?
5 or
4.5. How do you get a half of the spark? I don't know. Well, there's 2 plugs, so 1 fires, 1 doesn't. That's just, all right, if you got lost there, just, okay, don't worry about that. All right.
We got to make sure that exhaust burns.
Yeah. All right, 10, 11. All right. That right there is important to know. I'm a little worried that this part goes off into the weeds here. So therefore, the ratio of the speed of the magneto to crankshaft is the number of cylinders divided by twice the number of poles. So it's the number of cylinders divided by 2 times the number of poles is equal to the magneto shaft speed divided by engine crank speed. So let's see, I had an example here. 4-cylinder, 2-pole magnet. So 4-cylinder, 2-pole magnet. So number of cylinders, 4, divided by 4 is a ratio of 1 to 1. So the magneto crank speed is 1,000 RPMs, then the magneto shaft speed should be 1,000 RPMs. Let me see, let's try this. Curiosity.
9 cylinders.
Actually, I have that on here. I know the answer. But I was just thinking, probably going to get me in trouble here. I have a 6-cylinder engine. And I'm pretty sure that my magnetos, they're slicks. And they have 2-pole. So how fast is my magneto spinning at idle? We'll say idle. Idle is 500 RPM.
750.
So 6 over 4. I didn't bring a calc. Oh, I do have a calc right there. Equals. Can we do it this way? Engine crank speed. Would it work this way, the way I wrote it? 500x.
Yeah.
So yeah. So it'd be 6 times 5 equals 4x at 500. So 6 times 500, 30 equals 4x. Divide both sides by 4. It's 750.
Isn't it 3,000?
Yeah.
Sorry, 3,000.
No, it's 30.
Yeah.
It's 30
What's that? It's going real fast. 3,000. 3,000 might have. It ends up being 750, right?
Yeah.
750. So what's 750 RPM?
Magneto. That's right.
So where's coming in speed? Supposed to be. Yeah, it's actually 250 on slicks. 175 to 250, I think. Don't quote me on that. It's much higher. But I think it's around 250. So we're well outside that range, aren't we?
Yeah.
Is that right? 750. All right. What's it turning at when I do the RPM check at 1700 RPM? How fast is that magneto going?
1.5 times that.
Well, 6 divided by 4 equals 1.5. 6 divided by 4 equals 1.5. So it's 1.5 to 1. Which one's moving faster?
The magneto.
Magneto's faster. So 1700 times 1.5 equals. Oh, I'm doing it by myself? I got it.
2550.
2550. All right, 2550. Well, how fast is that magneto going at my red line, which is 2400?
3,600.
Yeah, I was gonna say.
Yeah.
3600. It's moving pretty damn fast.
How fast is it going at 3,600?
What's that?
How fast is it going at 3,600?
How fast is what going at 3600?
It's going 0 because the engine blew out.
I was going to say that. It's not. Engine broke. I do have it on here. What if it's a 9-cylinder 4-pole? Oh man, this gets crazy. 9-cylinder 4-pole. 9-cylinder.
So, yeah, 9 divided by 8.
So 9 divided by 8.
So what's your RPM?
Just 8 to 9. 8 to 9. So magneto speed is 1.125 times crank. Then I wrote, note, engine fires 4 point times per revolution. Magneto produces 4 sparks per revolution, which is 4 to 4.5. Engine requires 36 sparks for 8 revolutions. Magneto makes 36 sparks per 9 revolutions. So, anyway.
That is one of the questions.
What?
Is like how many sparks do you need for a 9-cylinder?
Oh, it is a Q&A question?
Yeah.
Holy crap.
Or 18. It's like 18 or something like that. Or 36 is the answer. I know that.
Okay, 36 is the answer.
Well, there's also one that had to do with, remember, it was a low tension ignition system. It was asking how many
That's what it was.
secondary coils you need.
Yeah, secondary coils. That's what it was.
One for each spark plug.
Yeah. Talk about expensive.
And heavy.
What is the, I don't know if I want to do this. What is the gear ratio? Well, we'll see if we have to do that. But I think right now people know, oh, what's going on? All right, there's a thing called a compensated cam. In fact, I meant to bring it over here. I found a whole drawer full of them. Compensated cam. Speaking of radial engines, so radial engines do not actually fire like a car engine, a V8, a flat 4, inline 6, all these other engines. There's exact degrees between when one cylinder fires and the next. Like a 4-cylinder, right? It's got to fire every twice. Fire 2 cylinders per 1 revolution, so that's 180 degrees. So every 180 degrees, a cylinder is going to fire. We can do the math on a 6-cylinder. But if we did the same math on a 9-cylinder and we said, well, a 9-cylinder radial, 9-cylinder, has to fire all cylinders in 720 degrees, we can't do the math and just go, well, what's 720 divided by 9? It doesn't work that way with the radial because of the way the master rod and the link rods, the whole thing kind of works around in this real funny elliptical pattern. It doesn't look elliptical, but it actually is by a few degrees. And so if you had a regular magneto with a cam that was regular, like that is, where it's just the same, it's just, 2 lobes, 180 degrees apart. If you did something like that, one cylinder would end up firing at a different time than a different cylinder, because you want them all to fire at the same number of degrees before top dead center. But since they're not all firing in the exact same degrees, your magneto then has to fire one little early, one little bit late. It's got to kind of follow the same pattern. And so how do you get the same pattern? Well, you got to have a compensated cam, which basically has 9 lobes on it. And so you're going to have one lobe that's going to be marked a little dot, and that's the number 1 cylinder, and the other lobes on there are spaced out according to how they're actually fire on the engine. So compensated cam is what that is. So holy crap, I wrote about as much as I just said. Let me see. In a radial engine, because of the way the master link rods are connected, the path of each rod is elliptical. In a 9-cylinder radial engine, you would expect each piston to reach TDC every 40 degrees, which is 360 divided by 9. It'd be 720 divided by 9, not that. But some cylinders are a little more than 40 degrees, and some a little less than. Well, we're not going to use that 40 degrees. Oh, I'm sorry, yeah, TDC, top dead center. Yes, every piston will reach top dead center in 40 degrees because every cylinder reaches top dead center. Prop goes around once, every cylinder reaches top dead center. Doesn't fire, follow that? Mm-hmm. Okay. Doesn't necessarily fire every time, but certainly it hits top dead center. Top dead center on exhaust, top dead center on power, but every around. So 360 divided by 9, yes, you'd expect every 40 degrees it would reach top dead center, but it doesn't. So some are a little bit. So we use a compensated cam. I'll put this one here. Compensated cam. Compensated cam has cam lobes properly spaced for a radial engine with the number 1 cylinder marked with a dot. Isn't there a Q&A question about that?
We haven't gotten that far yet.
Okay.
Done 1 and 2.
Well, now we got a problem, and you should have figured this out. If you take a magneto and you put a 9-lobe compensated cam on this, well, how is that going to work?
You gotta slow it down.
Then how many, so if I've got two lobes on this, how many?
2
Pole. I got 2 poles. So if I have a 9 lobe cam, then how many? 9.
You have to gear it down.
Yeah.
Or gear it down.
That ain't gonna work, is it?
We need a bigger magneto.
You're gonna need a bigger magneto. Not to mention, how you gonna fit that 9th one? It's kind of an odd number. It's not gonna work. So when you get into radial engines, then that kind of falls apart. You don't do that. And so then in that case, the cam must be driven off the distributor gear. Which turns at 1/2 crank speed. So that's radial engines. All right, so that's my only difference there for radial engines. Back to flat engines. The distributor gear speed. This one's easy. The distributor is always geared to drive at 1/2 crank speed. Why is that?
Because every 720 degrees of rotation on the crank, you have to fire all four. So if you're spinning the distributor gear that same amount, you're gonna hit all the sparks too quickly.
There we go. So it takes 2 times around to fire all the cylinders. So if the crankshaft has to spin twice to fire all the cylinders, how many times does this have to go around to fire all the cylinders? Once. So this goes around twice, this goes around. So the ratio is 2 to 1 or 1 to 2, 1/2. So the engine fire for every time the prop goes around once, this will go around halfway. Every time the prop goes around twice, this will go around all the way to fire all the cylinders. All right, things that are very important to know. 1, which direction does the magneto rotate?
Whatever it says on the.
Yes.
At the drive end.
All right, so if this is a S6LN-21,
Counterclockwise.
6 tells me it is, and the L tells me it is, left hand, and the 21 tells me it is, impulse. There's an impulse on it. All right, so left when, what, who? Pilot's perspective?
Drive in.
So I want you to think about this next time you think pilot's perspective. You tell me that this drives left from the pilot's perspective, we're going to go out to the Skymaster and you explain it to me because it's got one engine facing this way and one engine facing that way. So how in the hell would you figure that out?
We gotta turn around and look.
So, okay, so you turn around and look. So is the pilot's perspective when they're facing forward or turn around looking at the engine?
Or do you have 2 pilots?
Or do you have 2 pilots? One faces this way and you turn the other seat around so that it works.
Yes.
So that's silliness. It is not the pilot's perspective. If I had a new Cessna, one of the T-182s with the Lycoming engine, and I'm sitting and I'm the pilot, we'll all be pilots. Guess which way the mag's going to be sitting? It's going to be sitting there right like that in the back of that Lycoming engine. Then I jump out of my brand new T-182 and I jump into my 1977 Cessna 182 Q model. Guess where the magneto is? On the front, going this way. So that would be ridiculousness to say that it is from the pilot's perspective because engines go all different ways. So it is when viewed from the drive end. What's the drive end? This or that?
This.
This is correct. This end is the drive end. It's when viewed from the drive end. Because guess who's supposed to work on it? Mechanics or pilots? Mechanics. They're talking to us. It's left hand when looked at this way. Left hand. Left hand. If it's an S6RN, then it's right hand. And it goes right hand. All right, going back to it's a left hand, so we keep things straight. It's a left hand when viewed from the pilot's oh my God. From not the pilot's perspective, from the mechanic's perspective, which way is the distributor going?
Left also.
Also left, because
It's geared.
it is geared and it reverses, but I reversed it. So if I'm looking at it this way and I turn this to the left, guess which way
It's going to the right.
it's going this way. And it's going that way. But now it's going to your left, hopefully, because it's to my right still, so, because I'm on the opposite side, so. All right, that's super important. And that is, well, if you don't know much about magnetos, like, I don't know how it works, I'm completely lost. Well, you're not going to get through your oral practical, but aside from that, you'll get lucky. You will almost guaranteed have a magneto project on your oral practical. It always came up on the test I had to give. And they range from verify timing to install. And sometimes it's almost easier if you install. It's terrible. We'll get into that. It's so easy. It's so simple. Is it not simple?
Simple.
I mean, Elijah could do it over and over and over like that, right?
Yes.
You did it, didn't you?
Yes.
It was so simple.
No.
But now you know.
It's probably easier now that you have this class. You're like, oh, now I get it.
Oh, thank goodness.
All right. Okay, so we got that. Left impulse. M. Point M. Firing order of a magneto. M-A-G-N-E-T, a magneto. I don't know how you can remember this. I don't have a little thing. It's just something you have to memorize. In a 4-cylinder magneto, the firing order of a magneto is 1, 2, 3, 4. If it's a 6-cylinder magneto, it's 1, 2, 3, 4, 5, 6. If it's a 9-cylinder, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the firing order of a magneto. Why do I say that? Well, my shop, we must have been one of the only places in the country that overhauled these old lunchbox magnetos. Thankfully, this comes off. And everything's the same. If I say, well, how does this work? It's exactly the same thing I just said. The only difference really in this magneto is that instead of sending it to a finger that goes around, it sends it to this high impulse energy to the drum. And the drum is energized, and a tab is going to sweep across. And if the tab is lined up with one of these inside, I'm going to have one of the cigarettes, is what you call them, then it will spark to that cigarette, which goes off to that cylinder. And so it's timed that way. But they're kind of cool. So there's like one tab right there. Here comes the other tab, so it'll fire the front, the back, the front, the back, the front, the back, and so it'll be off here, off there. So that's how they work. Other than that, it's exactly the same. So we overhauled them, and we did them. We did them to historical accuracy. And on the top here, you can't really see it, but there's 4 little circles right there. And those little circles took little white tabs, and we'd have them printed up and put them on there. And the tabs said 1, 2, 3, 4, and that represented the firing order of the magneto. And then on the front, there's a little tab. And that had a little arrow this way or that way. And so that did. Told you the rotation. Is it firing this? Because right here, this right here, that's a window. And we put a little piece of plastic in there. And that little piece of plastic allowed you to look in and see this gear. And when the white tooth went by, there's no white tooth. It should be this one right here, because there's a white dot back there. I can see it. When the white tooth goes by, you knew that that was where the point should open. And that was the number 1 cylinder, so you time it to number 1. So we'd send them back out, and the mechanic would say, all right, line up the white tooth in the window with this little pointer right there. That's the number 1 cylinder. This is labeled, whichever one it was, I don't remember now. That's labeled number 1. So this wire, it says number 1, goes to which cylinder? Number 1. They'd say, okay, that's number 2, so number 2 goes to number 2. Number 3 goes to 3, 4 goes to 4. And then they would call us up and go, "This damn magneto doesn't work at all." And I would just say, "Swap the 2 and the 4. I mean, sorry, 2 and the 3. You got them backwards." "Well, what do you mean?" I said, "Well, the firing order of the magneto is 1, 2, 3, 4, but the firing order of a 4-cylinder engine is 1, then 3, then 2, then 4. So 1 goes to 1, 2 goes to 3, 3 goes to 2, and 4 goes to 4. But they didn't do it that way. So they had these 2 crossed.
They had half of it right.
And then I said, "Hey, you know it'd be really smart," when I got in the mag shop, "why don't we have a tag printed up that says that instead of sending out something, letting the poor people install the whole engine and magneto and then job security." All right, you want a story?
Sure.
Okay.
Yes.
So, I'll do my best on this one. I wasn't in the engine shop or the mag shop at the time, but we had, and this is several lessons learned. An engine got overhauled in our shop, and as it often did, an engine was overhauled at this time in the history of the company, and it was sent off to the customer, and the customer would do the install and test run, which would technically violate the disassemble, clean, inspect, repair, and test, repair, reassemble. Wasn't tested, so is it an overhaul? Mm-mm. Nope. There are service instructions that say that will allow you to do a test on an aircraft engine in an aircraft, but it wasn't done that way. I'll just be honest with you. Nobody does it that way in the field because it's actually kind of complicated because you have to have calibrated gauges and everything has to be monitored. So you have to have all cylinders monitored, all EGT have to be calibrated on and on. But this is a long time ago, and wild, wild west. So this engine had been built. It was put on like a Cub, some Cub or a PA-12 or something like that. I don't remember exactly. It was a 4-cylinder, and pilot flew it for a while, and it wasn't long. Did the brake, did the test run, then went and flew it, and kind of called, and he's like, because I just really expected more power out of this engine. It just doesn't produce really the same amount of power that it used to, and I was expecting more from a new engine. So I'm like, well, bring it in. We'll take a look at it, And so I brought it in, and the guy who built the engine and probably the mags and everything, he look and run it, compression test. Couldn't figure it out. Now on an engine with a fixed pitch propeller, in the type certificate data sheet, there's something called the static RPM. And if you have the right propeller, when you have the airplane brakes locked and you go to full power, you should reach a very narrow range of RPM with that propeller. It's called the static RPM, and you can only do it with the fixed pitch. And, probably check static, and probably was a little low. And, I don't know, took the carb off. They checked the carb. I was doing something else. But I would walk by because it was interesting. Hey, what you doing there? Okay, that's kind of cool. And get back to my job. And I don't remember what I was working on. But anyway, then it couldn't find anything. So it was handed off to another mechanic. And, and I don't remember exactly what, but this is where you have to be really careful. Walking by, what you doing? And a mechanic gets stuck. You get stuck. Sometimes you ask people for help. Hey, what do you think I should do? It's the worst thing in the world to do. Never ask somebody who's not fully engaged, because I've done it to other people. I threw out really stupid ideas. We ruined a good set of floats in a carburetor. I was one of those things walking by. What you doing? Hey, maybe there's something in the carburetor. Yeah. I guess you could just blow it out with shop air. I don't know. Walk out. And then the guy actually did it, and of course it just collapsed the floats to nothing because it pressurized the float chamber. It just destroyed the floats. Well, there's a problem. The floats are flat, huh? Anyway, I'd say to make a long story short, but it's too late. This was a C85-8 engine, where most of them are C85-12 engines. I remember that part. A C85-12 has a starter, and a C85 does not have a starter, a -8. And because of that, they run a different gear pattern in the back of the engine, which means that instead of having an S6 LN, it had an S6
Arm.
RN. And the person who ordered the brand new ignition harness ordered it for the most common, which would be a C85-12 starter. Well, I think that has the L lens on it, and this has the R ends, if I'm not mistaken. It's, or it's backwards. So when you order the new ignition harness and the ignition harness shows up, it's conveniently marked for you. It has top 1, top 2, top 3, top 4, bottom 1, bottom 2, bottom 3, bottom 4. So let's see if we can figure this out. So an S6 RN, the firing order of the magneto is,
1, 2, 3, 4.
let's do it this way. 1, 2, 3, 4. But the firing order of, would be right, so that'd be the RN. So the LN would be 1, 2, 3, 4. So,
Half of it was right.
guess what was running?
2 cylinders.
2 cylinders.
2 cylinders.
He was actually able to get it off the ground with 2 cylinders.
I remember coming by, and, at this point I kind of got my head involved, because everybody'd scratch it and they just like, I can't figure it out. I'm like, well, we have a new ignition harness. What if it's, I don't remember how I figured this out because normally I'm not that smart. I said, well, if somebody ordered the wrong ignition harness and this one turns the other way, that would make 2 cylinders not fire. Well, that's just not going to work. Like, I think that would work. And I got a piece of paper. I'm like, see how that would work? I guess it would work. And then we tried it, and it was like, oh, yeah, I mean, yeah. Guys flying around at 2 cylinders. I don't know how the hell they even got off the ground, like you said. It's like, what the hell? Weird things happen.
Freaking power.
So sometimes troubleshooting is, what did you change? All right. What did you screw up? All right, so all that. Firing order of the magneto, 1, 2, 3, 4, 1, 2, 3, 5, 6. All right, you got that. Number 1 cylinder is the number 1 cylinder position. The number 1 cylinder is clearly marked.
Hey, Kevin,
Asterisk, because it's not clear. Yeah.
is there a reason why they designed it that way? Like where it goes 1, 4, 3, 2?
The engine?
Yes.
For smoothness. And so it's funny because it's 1, 3, 2, 4. So it's right, right, left, left, right, right, left, left. I would have thought it'd be right, left, but it doesn't. It goes 1, 3, 2, 4, 1, 3, 2, 4. Or it's the other way around, 1, 3, 2, 4. Depends on the engine.
It's funny, like a Volkswagen is like 1, 4, 3, 2.
That would be opposites.
Yeah.
I know.
To say an inline 4 is 1, 3, 4, 2. That way you have.
1, 3, 4, then 2. Well, that makes sense. 1.
Well,
Yeah.
no, yeah.
And that's the way they do it. The firing order for 6 cylinders is different between Continental and Lycoming. I can never remember it is. See, number 1 cylinder is clearly marked. It's not necessarily. Like I said, the old Bendix magneto had it marked with the tooth and right there where the number 1 is. Bendix, you should know this because you did it. The number 1 cylinder is marked when the red chamfered tooth shows up in the window. There's a window right there. Okay, you guys painted the tooth, so that's when that is up. This finger is pointed towards the number 1. Trust me on that. So can you see the red tooth that you painted? Not the red dot. And that's why you never want to paint that red dot that lines up with the magneto gear, the rotor gear. You don't ever want that showing out here because it'll confuse somebody. So the only thing that's out here is the chamfered tooth that's red. And when that shows in the little window, then that is ready to fire the number 1 cylinder, which is that one right there. Slick is not so slick. And we'll talk more about it. But you get to the number 1 by putting a pin in this hole that says L or R or X, which we'll get to. So it's not clearly marked. It's
Until it breaks the pin off.
I was gonna say.
yeah. Let's see, do we still have the markings on these gears? There we go. Got the red gear. Both of them. It should be. Both firing one. All right. Let's see here. We got more time. Safety gap. Well, I've heard of the safety dance. You guys just aren't even old enough for that, so that crap I'm putting out. I have never seen a safety gap. I don't remember overhauling radial engines. I know we did it in our shop, but I don't think I ever did. So that's why I put some mags, some magnetos. Incorporate an internal gap. Let me just explain this for you. I'll explain it first. All right, so if I take a magneto that actually works, and I decide that I'm just going to sit here and just snap it just for the fun of it, I know better and I'll probably get shocked, so I'm not going to do it. But if I just sat here snapping it, I'm damaging the magneto. It has nowhere to spark out. There's no continuous path, but yet the magneto is rotating inside, which does have magnetic lines of flux. Those magnetic lines of flux are really cutting across a real primary. And when it cuts across that primary, the point's really open. And when the point's really open, that magnetic field that the primary made collapses across the secondary, which really creates a whole lot of voltage, probably as much as that can actually produce. But it goes nowhere. And so it built up and it looks for something. So if you got 20, 40,000 volts looking for a place to go, it will do its best to go somewhere, and that somewhere is going to be either from the coil to the case to try and make its ground back, or maybe one of these fingers, or it'll start wearing down the block on here. It will do some way. It's really going to try and find a way, or maybe it just doesn't. It just kind of, I don't know, stresses it out a little bit. That's really bad. That's why I say don't run these without a loop in it. Give it a place to actually go back to ground and give it a spark to go. Well, some of these older magnetos, and I'm pretty sure they're all the old ones that were on radial engines, they had a safety gap, so which is an internal gap, which is to say that if you were doing that to this magneto, it has an alternate path inside of it that would be bigger than the spark plug gap, but if it couldn't find a way, it's going to spark there. And it's safe for the magneto is where the safety comes from. It's not going to help you. It's not safe for you. Internal gap, that would give the secondary an alternate method to discharge the spark. In the event of an open at the plug, which is to say you didn't have the ignition harness on, you didn't have the spark plug grounded out, something like that. I did write a note. I don't want to write it. Number one cylinder is clearly marked. I had a subnote on that. Technically, any position can be number one as long as the magneto is wired correctly to each cylinder, but don't do that. So that is to say that I put the red tooth here, then I know that this is the number one. How do I know it's number one? Because I can look in there and see the finger going right to it. So this is the number one. And so if this is one, and this is the left hand, then the next one to fire is going to be this one. But if I wanted to, and I was a real jackass, I could in fact say, you know what, I'm going to make this one number one, and then this will be two. And what you're going to do is just cause everybody to hate you. But if you were in a Flight of the Phoenix scenario and you had to do that, you could do it. But I'm not going to write all that because you're like, why are you doing that? Safety gap, coming in speed. You know what? Let's just save that for tomorrow. So, coming in speed for tomorrow.